when performing electrical load calculations for panels in a series configuration, the correct approach is to apply any applicable diversity factors to the downstream panel exclusively. Once the diversified load for panel 2 is determined, this value is used to size the breaker in panel 1 that feeds panel 2. However, when calculating the total load on panel 1, the entire load of panel 2, before any diversity is applied, must be included at 100%. This method ensures accurate sizing of the upstream panel and feeder conductors. The National Electrical Code, or NEC, provides guidelines for calculating electrical loads and applying demand factors, often referred to as diversity factors. These factors allow for reductions in the calculated load based on the understanding that not all connected loads will operate simultaneously at the maximum rating. The NEC specifies various demand factors for different types of loads, such as lighting receptacles and appliances, in articles like 220. Firstly, calculate the total connected load of panel 2. This involves summing the volt-ampere requirements of all branch circuits and equipment connected to panel 2. For example, if panel 2 serves lighting receptacles and a small HVAC unit, you would add up the volt-ampere load of each of these components. Secondly, apply any applicable diversity or demand factors to panel 2 as permitted by the NEC. For instance, the NEC allows a demand factor of less than 100% for general use receptacles in certain situations. This means that you don't need to count all the receptacle load at its full rating, acknowledging that not all receptacles will be in use simultaneously. Thirdly, determine the feeder size and breaker size for panel 2 based on the diversified load. This ensures that the conductors and overcurrent protection are appropriately sized for the expected load. The diversified load represents the maximum current that is likely to flow through the feeder conductors under normal operating conditions. Fourthly, when calculating the total load on panel 1, include the entire connected load of panel 2 at 100% before any diversity factors were applied. This ensures that panel 1 is adequately sized to handle the maximum potential load from panel 2, even if the load is unlikely to occur continuously. This is a crucial step in ensuring the overall reliability and safety of the electrical system. For example, suppose panel 2 has a total connected load of 100 amps at 240 volts, which equals 24,000 volt amperes. After applying diversity factors, the diversified load of panel 2 is calculated to be 75 amps. The feeder conductors and breaker for panel 2 would be sized based on this 75 amps diversified load. However, when calculating the load on panel 1, you would include the entire 100 amps or 24,000 volt amperes from panel 2 at 100%. This ensures that panel 1 has sufficient capacity to supply the maximum potential load of panel 2. The reason for this approach is to account for the possibility that panel 2 could draw its full rated load under certain conditions. While diversity factors are useful for reducing the calculated load on individual panels and feeders, it's important to ensure that the upstream panel has sufficient capacity to handle the maximum potential load from all downstream panels. This helps to prevent overloads and ensures the reliable operation of the entire electrical system. It's also important to consult the NEC and local electrical codes for specific requirements and guidelines related to load calculations and diversity factors. These codes provide detailed information on how to calculate electrical loads for various types of occupancies and equipment. Some specific examples of NEC articles that are relevant to load calculations include Article 220, which covers branch circuit, feeder, and service calculations, and Article 430, which covers motors and motor circuits. These articles provide detailed guidance on how to calculate the electrical loads for different types of equipment and occupancies, and they also specify the applicable demand factors and diversity factors that can be used to reduce the calculated load. In addition to the NEC, local electrical codes may also have specific requirements related to load calculations and diversity factors. It's important to consult both the NEC and local codes to ensure that you are following all applicable regulations. Understanding the difference between connected load and diversified load is crucial for accurate panel sizing. The connected load represents the sum of all individual loads connected to a panel, while the diversified load takes into account the likelihood that not all loads will be operating simultaneously at their maximum rating. By applying diversity factors appropriately, you can reduce the calculated load on a panel and feeder, which can result in cost savings and more efficient use of electrical equipment. However, it's important to ensure that the upstream panel has sufficient capacity to handle the maximum potential load from all downstream panels, even if that load is unlikely to occur continuously. This ensures the overall reliability and safety of the electrical system. Furthermore, consider a scenario with panel 1 feeding panel 2 and panel 2 then feeding panel 3. You would apply diversity to panel 3 exclusively to determine its diversified load. Then, you would size the breaker in panel 2 that feeds panel 3 based on this diversified load. When calculating the load on panel 2, you would include the entire connected load of panel 3 at 100% before any diversity factors were applied to panel 3. Finally, when calculating the load on panel 1, you would include the entire connected load of panel 2 at 100%, which already includes the entire connected load of panel 3 at 100%. This cascading approach ensures that each upstream panel has sufficient capacity to handle the maximum potential load from all downstream panels. Always refer to the latest edition of the NEC and consult with a qualified electrical engineer or inspector to ensure compliance with all applicable codes and regulations. Accurate load calculations are essential for ensuring the safety and reliability of electrical systems. By understanding the principles of diversity and demand factors, you can design and install electrical systems that are both efficient and safe. Incorrect load calculations can lead to overloaded circuits, nuisance tripping of breakers, and even electrical fires. Therefore, it's crucial to pay close attention to detail and follow all applicable codes and regulations when performing load calculations. Furthermore, consider the impact of future load growth when sizing electrical panels and feeders. It's often prudent to oversize the panel and feeder to accommodate future expansion or increased load demand. This can help to avoid costly upgrades in the future and ensure that the electrical system can meet the changing needs of the building or facility. Also, remember to properly document all load calculations and assumptions. This documentation should include a detailed breakdown of the connected loads, the applicable demand factors, and the calculated diversified loads. This documentation can be helpful for future reference and can also be required by electrical inspectors during the permitting process. In summary, the process involves a few critical steps. Firstly, determine the total connected load of the downstream panel, which is panel 2 in this case. This is the sum of all the individual loads connected to panel 2 without any reductions. Secondly, apply any applicable diversity or demand factors to panel 2, as permitted by the NEC or local codes. These factors allow you to reduce the calculated load based on the understanding that not all loads will be operating simultaneously at their maximum rating. Thirdly, size the feeder conductors and overcurrent protection for panel 2 based on the diversified load. This ensures that the conductors and breaker are appropriately sized for the expected load. Fourthly, when calculating the total load on panel 1, include the entire connected load of panel 2 at 100% before any diversity factors were applied. This ensures that panel 1 has sufficient capacity to handle the maximum potential load from panel 2, even if that load is unlikely to occur continuously. This approach ensures that the upstream panel is adequately sized to handle the maximum potential load from the downstream panel, while still taking advantage of diversity factors to reduce the calculated load on the downstream panel and feeder. Always consult the NEC and local electrical codes for specific requirements and guidelines related to load calculations and diversity factors, as these codes may vary depending on the jurisdiction and the type of occupancy. Accurate load calculations are essential for ensuring the safety and reliability of electrical systems. When dealing with receptacle loads specifically, the NEC provides guidance on how to calculate these loads based on the type of occupancy and the number of receptacles. For example, in dwelling units, the NEC requires a minimum load of 180 volt amperes for each receptacle outlet. In commercial occupancies, the load requirements may vary depending on the type of business and the expected usage of the receptacles. It's important to carefully review the NEC requirements for receptacle loads and apply them appropriately when performing load calculations. Also, remember to account for any dedicated receptacle outlets that are used for specific equipment or appliances, as these outlets may have higher load requirements. For example, a dedicated receptacle outlet for a refrigerator or freezer may need to be calculated at 100% of its rated load. In addition to receptacle loads, lighting loads also need to be carefully considered when performing load calculations. The NEC provides guidance on how to calculate lighting loads based on the type of occupancy and the square footage of the building. For example, in dwelling units, the NEC requires a minimum lighting load of 3 volt amperes per square foot. In commercial occupancies, the lighting load requirements may vary depending on the type of business and the expected lighting levels. It's important to carefully review the NEC requirements for lighting loads and apply them appropriately when performing load calculations. Also, remember to account for any special lighting requirements such as high-intensity discharge or HID lighting or LED lighting, as these types of lighting may have different load characteristics. When calculating the load for motors and motor-operated equipment, the NEC provides specific requirements in Article 430. This article covers the sizing of conductors, overcurrent protection, and other components for motor circuits. It's important to carefully review Article 430 and apply its requirements appropriately when performing load calculations for motor loads. Also, remember to account for the motor's horsepower rating, voltage rating, and full load current when calculating the motor load. In addition to the NEC requirements, it's also important to consider any local codes or regulations that may apply to motor loads. Some jurisdictions may have additional requirements for motor starters, disconnect switches, or other components. Always consult with a qualified electrical engineer or inspector to ensure compliance with all applicable codes and regulations when dealing with motor loads. When calculating the load for HVAC equipment, it's important to consider the equipment's cooling capacity, heating capacity, and electrical characteristics. The equipment's nameplate should provide information on its voltage rating, amperage rating, and power factor. This information is needed to accurately calculate the electrical load of the HVAC equipment. Also, remember to account for any auxiliary equipment, such as pumps, fans, or controls, that are associated with the HVAC system. These auxiliary components may also have electrical loads that need to be included in the load calculation. In addition to the equipment's nameplate information, it's also important to consider the operating characteristics of the HVAC system. For example, the system may have a variable speed drive, or VSD, which can reduce the electrical load during periods of low demand. It's important to understand how the VSD affects the electrical load and to account for this in the load calculation. Also, remember to consult with a qualified HVAC contractor or engineer to ensure that the load calculation is accurate and that the electrical system is properly sized for the HVAC equipment. By carefully considering all of these factors, you can ensure that the electrical system is capable of providing the necessary power to the HVAC equipment without overloading the circuits or causing other problems. The NEC provides specific requirements for calculating the load for electric ranges, ovens, and other cooking appliances. These requirements are based on the appliance's kilowatt rating and the number of appliances. It's important to carefully review the NEC requirements and apply them appropriately when performing load calculations for cooking appliances. Also, remember to account for any additional loads such as lighting or receptacle outlets that are located in the kitchen area. These additional loads should be included in the overall load calculation for the dwelling unit. In addition to the NEC requirements, it's also important to consider any local codes or regulations that may apply to cooking appliances. Some jurisdictions may have additional requirements for range hoods, smoke detectors, or other safety devices. Always consult with a qualified electrical engineer or inspector to ensure compliance with all applicable codes and regulations when dealing with cooking appliances. Electric water heaters also have specific NEC requirements. The load is usually considered to be continuous. The size of the water heater is going to influence the load calculation. When considering non-coincidental loads, you have to factor in those as well. Firstly, identify all the loads that are unlikely to operate simultaneously. Secondly, determine the largest of these non-coincidental loads. Thirdly, include only the largest non-coincidental load in the total load calculation. This approach prevents overestimating the total load by adding multiple loads that are unlikely to operate at the same time. However, it's important to carefully evaluate the likelihood of each load operating simultaneously and to use engineering judgment to determine which loads are truly non-coincidental. In addition to non-coincidental loads, there may also be intermittent loads that operate for only short periods of time. These loads may not need to be included in the total load calculation if they are unlikely to significantly impact the overall load demand. However, it's important to carefully evaluate the characteristics of these intermittent loads and to use engineering judgment to determine whether or not they should be included in the load calculation. Remember to always consult with a qualified electrical engineer or inspector to ensure that your load calculations are accurate and comply with all applicable codes and regulations. Accurate load calculations are essential for ensuring the safety and reliability of electrical systems.